Hello, and welcome everybody. So, yeah, another early stream. So, today I will probably stream for a couple of hours before I would have to take a short break, and then we're gonna start our gaming stream. So, we'll see how much I would be able to do during the stream, but hopefully we can make some nice progress. So, yeah, yesterday we managed to actually make the whole Kubernetes setup work, and actually the game server is now runs there successfully. One thing that I want to change a little bit is I wanted to make this connection linking configurable. So here what we have on the gateway side, we configure the login host name, and it should point to the login service. For a login, we just publish the connection, so it becomes available from every IP address. For Vault, we do the same, and we also connect it to login with in the same way. For Zone, again, we connect it to Vault, we expose also the listener. So what I want to do instead is, if this login connection and Vault connection is defined in here, only then we configure that. So let's see. What would be the best way? So first of all, I want to move this one to the bottom. So let's say if we have this, only then we add this environment variable. So let's see. Oh, by the way, also I need to start Minikube. Okay, so Helm template. And let's see, right now we do have this login connection on the gateway. So we should be able to see it. Zone server. Vault. This is the gateway. So yeah, we have login host. Okay. Now if we comment it out, yeah, now we don't have anything. Okay, good. So that works. Let's do that for other components. So again, this is for the login connection. That's good. And this one is for the old connection. Okay. Okay, so now this is optional, so that means that we can manually specify that thing. Maybe we can do it in a little bit more convenient way. So we have two options here. First is to connect to a service within the same deployment. I mean, not the deployment in terms of Kubernetes terms, but deployment as Helm release, I guess. So it's either this or we connect to something else. We can actually do it this way. So we don't need the type, technically. We don't need the type. So it's either the ID or we can maybe set it as host. So let's test this one, this example. So host, this will be, I don't know, tests login server dot local. So if ID is defined, then we do it like that. No, oops. Else if we have host, then we just specify that instead of this whole thing. And this should be login. This should be world. No, wait. This is world. And this is our own thing. Okay. So if ID is specified, we generate that value. Otherwise, if host is specified, then we do that. Otherwise, we don't do anything. Let's see if that works. So I'm gonna comment out this thing for now, just to have it more convenient. And test this gateway server. Okay, so now we have that value. If ID is specified instead, then yeah, we have that automatically generated thing. And if nothing is specified, we have an error. How do I do and in Helm chart syntax? If and. Great. Is this like Go expressions or something that I can Google? Oh my god, this is so stupid. But yeah, I guess if and something like that. Wow. Oh, now that's the host. Okay. So we can work with that. Okay, we also need this second condition here. Okay. So now we are able to do that. Another thing that I wanted to do is maybe we can include some environment variables similar to this. So if we don't set anything, it should be empty. Yeah. But now we can do something like yep. Okay, good. So now we are able to do that. What else could we need? Have ports, but we don't really care about those to be configurable. Have resources, have volumes. Command. I don't think we need that. So yeah, we should be good here. Now we can actually define custom links between the components. What else do we need? Wait, I wanted a dashboard. So right now we don't have anything deployed here. That's good. So what I wanted to do is I wanted to, first of all, delete the test. We don't need this thing at all anymore. Well, have HPA. We have HPA. I don't think I need that. I'm not gonna bother with autoscaling for now. I just need to make sure that I can do scaling if I want to. We covered this deployment thing. Yeah, we basically ported all of this. We don't have an ingress, so we would have to figure out one thing, but that's gonna be in a moment. I don't think we need nodes. Yeah, for now we don't need that. Service account, that's also good. Helm ignore when building packages. Yeah, I guess let's add that thing here. We have the chart defined, values, we have our custom values. I think we ported everything from here that we may need. Charts, empty. So now we can just delete this test folder that we created. We don't need it anymore. Now the old one, do we still need that? I think we ported everything from here. Double checked that yesterday. Yeah, this looks good now. We can get rid of that. I ported the service basically exactly as it is right here. Config map, yeah, I also implemented that. Database deployment, yes, we've done that. And database service, okay. So templates are fine. Chart, readme, did I port the readme? I'm pretty sure I did, yeah. Oh, I even had some notes on the service type, I forgot about that. Okay, Crustal local IP, proxies to pods, headless servers, DNSA records point to pod IPs. Open support on each node that proxies connections to service. Load balancer, okay. But yeah, we have that in the README. So we don't care about that. values, we ported this. Yes, we ported that. What about the settings? These are just links between the services and to the database, world ID. Yeah, nothing special. So we can get rid of that old folder as well. Now let's move up here and move everything from the new folder to here. And the new folder can be gone. Okay. Okay, this looks good. Let's check out the settings that we put in here. This is just the production copy of nlock config. And what I did is I just enabled trace for now. It's fine. Yeah, gateway empty, gateway staging disables encryption. Sure. Login. World. Zone server. Right, so by default, we set the zone, supported zone groups to empty, but then each type of the, oh, this is a problem. So I changed in the values, I changed the ADs. So I simplified that a little bit. So we don't have Ymirheim prefix here anymore. And we use this directly. So I also need to change the config files. So this is Oscar Dungeons, Oscar Fields, Towns, Transport. Okay, so we have that. Alt server. Sure. Okay, so this is good. Have the config files. Now I need to decide how these config files actually supposed to work. Do we commit them to the repository? Probably not. This is like an example of how the config files should be placed when we do the actual deploy. But these could contain some sensitive information in the future. So it's probably not a good idea to commit these to the repository, but it's good to have structure like this. So maybe we will have like conf-example, but probably that's for later. For now, it should be good. Should be good. Config map, deployment. Service. Now for the database, this has to be explicitly stated that this is a test database, not just something. So maybe it's a good idea to rename it to test-db or test-db. So then here we need to change this. And service. Also, yeah, we could probably change the service name. Not just DB, but test DB. Okay, and we need to link it in the config files. Actually, I can configure this automatically. Not sure if I should do that, but I can. Because yeah, this depends on the release name. This depends on the full name. So yeah, the chart name, I mean. Hello, Aninia. Good morning. How are you doing? Good morning. So, maybe I will move it. Also, this thing, one second. We probably need it for the zone server to have something like gateway listener host, and we set something like zone server.local. So now here, if we have that defined, gateway listener, so if we have this thing defined, then we just use it as the host name. Otherwise, we generate the host name. Let's test if it works. Okay, zone server, gateway listener host name. So this is generated. We have the release name prefix. If we comment this out, yes, now we have our custom host name. Okay, good. Okay, this should be good. So what we have left is just the IP addresses and ports. Why do we have the listener port? 6301. What's the default one? Yeah, it is 6301, so we can get rid of that. It's just we need the listener IP address to be different. Actually, I want this to be a little bit more robust. So gateway listener, if host is defined, we set the host. Otherwise, if this if auto is defined, auto is true, then we generate this automatically. Otherwise, we just skip it. So this will give us an option to now this is world host. Okay, so this is good. So if we uncomment this, it will be a custom host. Yes. No, here. And if we do auto true, then it will generate the service name. Yes. And if we don't have it, then it just removes everything. Just listener IP and connection to the vault. And we also can comment that out. There we go. So yeah, it's highly configurable now. Okay, I was working on the test DB, right? I don't think I finished. So the service is renamed to test DB everywhere. Deployment is also renamed. Now, connection to the test database. This is changed, this is changed, this is changed. Okay, so it should be fine with the test database. It's now called testdb, sure. Now, can we make this optional, like automatically configured if we have the testdb? Yes, we actually can do that. So what we can do is in the app deployment, we don't even have to check the service type. We can just forward the environment variables. So here, for example, if we have values testdb defined, right? Yeah, if we have testdb defined, then we can just configure it automatically. How does that look like? So for login server, we have database login __ connection string. And let's just copy this for now. And we can automatically generate the host name like that. We know the port. We just need the DB name, DB user, and DB password from the values. So this is values test DB name. This is username, DB user. And this is DB pass. And we need to duplicate that for login log database and for the world databases, world and world log. And we don't care that it's gonna be passed to the gateway even. It's not connecting to any databases, but that should be still good enough. So if this is defined, now we have that. Let's see if that works. Yeah, I can see that. So for the zone server, we have that release name, Ymirheim server test DB. Okay, and it should be true even for the gateway. Yes. Okay. So if we comment out the test DB section, those should be gone. Yes, and those are gone. And you're supposed to configure those manually. Okay, good. So now we can get rid of this. Wait, no, let's not get rid of that completely. Let's just put some random IP address. And we will comment this out. So we will know that it's optional. It's only needed when you need it. Okay. Now I'm tempted to do the deployment. So this should be good. Let's format this just a little bit. So we have gateway connects to login, have login, we have world connects to login, have zones, They connect to old, and I have an automatic gateway listener. I need to set that for every single one. Okay. Looks good, I think. Let's take a look at the template. Oops. Okay, let's try to do the deployment. I'll install YH dot. Yeah, this error is weird. I tried to Google it, couldn't find anything. But yeah, it goes away when the services fully start. Like that. I assume that may be because of like incorrect order of services being registered in Kubernetes. Like it registers that it needs a config map, but the config map is not there. Maybe, I don't know. But okay, let's take a look. We have login. Okay. So yeah, it did connect to the database automatically. That's already good. Gateway connections. She didn't say... Oh yeah. Oh wait, status is offline. Is this up to date? Huh, the world is offline. Something's not right. Not quite. So dungeons, fields. Oh, we have something. So we have dungeons, we have 2 fields, we have towns. Transport. Transport is missing. Escort transport. I forgot to rename one last file. Now we should be good. So let's check out the world pods. Fields, towns, transport, dungeons. Status is good. And we have zone instances created. Good. What does login say? Where is login? Here's login. It says that the status is good. Okay, so we are running. That's perfect. So I wanted to test one more thing. So let's uninstall, oops, uninstall this, oh my god, deployment. And I wanted to test this, so name overrides. So this should override whatever we have, like Ymirheim server. No, in the names, we have release name dash Ymirheim server dash and then something. Hello, Daldark. Good morning. So now let's check the templates. Yeah, now we have just a very small prefix. So it should be much more readable in the dashboard if we don't have any other services. So let's test this. Yeah. Gateway login, test DB, old zone escort engines. Okay. This is nice. I like this. Now we have much shorter names. The pods are still a bit weird, but yeah, that's just because of the replica sets and the deployments. So we have the deployment ID, we have replica, index within the replica. Actually, not the deployment ID. I'm not sure what this is specifically. Actually, let's see. Deployments. Let's open gateways. So what is this? Yeah, this is replica set. So replica set has its own name auto-generated, and within the replica set, each pod has an additional thing assigned to it. Okay, I see. Okay. Okay. Okay, I like this. So let's uninstall. Bring this back to the default thing. And I want to commit whatever we have right now into the repository. Because this is already good, this is already working. I didn't have it in a fully working condition like this yet in Kubernetes. So let's see. I just want to make sure that we don't expose any secrets. Oh, this DB can be also renamed to test DB. Have this uninstalled, right? Yes. Okay. Okay, looks fine. What do we want? Kubernetes setup, update it. Now it's well, wait, how do I say it? Kubernetes setup updated. I don't know, whatever. I wanted to add, so maybe it's like a fully working minimalistic implementation or something like that, but whatever. It's our first commit about Kubernetes so far, so it's fine. So now what do we do? Yeah, one big thing that I still need to figure out is gateway server needs to know the actual real IP address of the connector, the connection, incoming connection. That could be tricky. So let's see, what can we do about this? Kubernetes real IP address. So the tricky thing is this is not an HTTP protocol. We are not using ingress. In normal Kubernetes setup for some kind of web application or REST API, it would be a very trivial task just to forward the IP address from the ingress. But here we have a raw TCP connection. And is this Nginx? This is not what I can use. TCP. The problem is everything on the internet talks about the freaking HTTP protocol. I'm not using that. I need a real TCP connection IP address, but I guess this is not possible if I use this service with cluster AP. Let's Google that. So service types, cluster AP exposes the service on a cluster internal AP. Choosing this value makes the service only reachable from within the cluster. This is the default that is used if you don't explicitly specify type of the service. You can expose the service to the public internet using an ingress or a gateway. Node port exposes the service on each node's AP at a static port, the node port. To make the node port available, Kubernetes sets up a cluster AP address, the same as you would have requested cluster AP. Load balancer exposes the service externally using an external load balancer. Does not directly offer load, but yeah. External name maps the service to the components of the external name field, for example, to the host name. The mapping configures your cluster DNS server. Oh, yeah, I understand that. What did I have in my notes again? In the README? So services, type cluster AP, default service allocates a cluster local AP, proxies to pods. Cluster AP, type cluster AP with cluster AP set to none. Cluster AP none. So this is when service external APs are not defined. Headless service, DNS-A records point to pod APs. Headless service. Okay. So looks like this doesn't do the proxy, right? Instead, it just creates DNS-A records that point to the pod AP addresses. Maybe this is something that we can do. And this cluster AP with external IPs routes traffic that comes to an external AP as destination to the service. An external IP should be associated with any node in the cluster. Okay, node port opens a port on each node that proxies connection to the service. Okay, load balancer, we don't care about that. So let's try, so cluster AP equals none. That is the case when we have service external APs commented out. What if we deploy this? So this should just point to the pod AP addresses. Headless service. Okay, so let's see in the service for gateway, cluster AP none. So this is the same as it was with the login. The problem is I don't think we can connect to the service from outside. What the hell? Oh, I need administrative permissions for this. That's stupid. So let me see if I connect to that. I don't think I can. Yeah, I can't. All right. So if we're using just normal services, this is the only way to expose a service to the outside world without having any kind of custom proxy or ingress. Right. This is a problem. Node port. If you set the type field to node port, the Kubernetes control plane allocates a port from a range specified by a service port range flag. Each node proxies that port, the same port number in every node, into your service. Your service reports the allocated port in the specs field. Using node port gives you the freedom to set up your own load balancing solution to configure environments that are not fully supported by Kubernetes, or even to expose one or more nodes' IP addresses directly. But it is a proxy still. The problem is I cannot use proxies for TCP connections, raw TCP connections. For a node pod service, Kubernetes additionally allocates a port, TCP, UDP. Every node in the cluster configures itself to listen on that assigned port and to forward traffic to one of the ready endpoints associated with that service. You'll be able to contact the node port service from outside the cluster by connecting to any node using the appropriate protocol. The thing is, I don't think I can use services for gateway server instances. I need to actually open a native port on a node to get the real connection IP addresses. Oh, there we go. This is probably one article that can be working for me. So the plaintext HTTP protocol has a number of X-forwarded headers that covers this for proxies which decrypt traffic. But what if you're using TLS or TCP, which works at a lower level of OSI model? So demystify the proxy protocol and show you that you can even implement it yourself with a few lines of Go. Show you how to enable it for your intense TCP tunnel servers, how to configure K3S with traffic v2 to publish real IP address of clients. You may have seen proxy protocol in the dashboard of your cloud provider. Do I have that? I don't think so. At least not in Minikube. It's an option that many of us can gloss over. That's until we need the source IP address for any clients that connect to our services for rate limiting, billing, login, and access control. This is exactly what I need. The spec of the proxy protocol was written by Willy Thoreau whilst working on HA proxy. We have plain text and binary. The primary difference, so version 2 is the binary. Hopefully this is what we use. Primary difference is that processing a binary header is more performant. It doesn't require, yeah. Here's an example of what it may look like to perform a HTTP request with a proxy protocol header v1 format. To perform an HTTP request. Okay. So proxy protocol, client IP, node balancer IP, client origin port, node balancer port. Okay, so how can I retrieve this information? I assume I need to configure the pod somehow, or the service. Wait, what? Inlets CTL. Enable proxy protocol v2 for inlets pro. HTTP tunnel servers can already send headers, so let's focus on TCP tunnel servers that can be used for a TLS terminating proxy running inside our local network. We need to create an exit tunnel server in TCP mode. I don't understand what they're trying to do. When I need to customize a tunnel server, then I prefer using DigitalOcean because they send a convenient email with a So what is this inlets pro? What is that? When I need to customize a tunnel server, then I prefer using, wait. We'll need the password associated with the box to provide the sessions for that inlets pro TCP server command. What is that? First, I'll show you how to set up a tunnel server and enable proxy protocol v2. Then I'll configure with continue with K3S and traffic. If you're using another tool, then you can stop before we get that far and look up its specific settings to enable proxy protocol, since it's not usually on by default. And let me see. So this is example for proxy v1. And yeah, basically it just sends a message before anything else when you connect. So maybe that means that we can enable this proxy protocol in Kubernetes. Hopefully they can show how. So Kubernetes proxy can add this header when there is a new connection. And maybe I can handle that directly in the gateway server. That's traffic. Cert managers. What the hell? This guy was talking about raw TCP protocols, and now we're back to HTTP. Wait. External traffic policy. Cluster to local. Where is it? I don't see it. What? But okay, let's see. External traffic policy. When creating a service, you have the option to automatically creating cloud load balancer. This provides an externally accessible IP address that sends traffic to the correct port on your cluster nodes, provided your cluster runs in a supported environment, and is configured with the correct cloud load balancer provider package. You can also use ingress in place of service. So type load balancer, right? So this command creates a new service using the same selector as the reference source. Finding your IP address. Preserving client source IP. By default, the source IP seen in the target container is not the original source IP of the client. To enable preservation of the client IP, the following fields can be configured in the spec of the service. External traffic policy denotes if this service desires to route external traffic to node local or cluster-wide endpoints. There are two available options: cluster, default, and local. Cluster obscures the client's source IP and may cause a second hop to another node, but should have good overall load spreading. Local preserves the client's source IP and avoids a second hop for load balancer and node port type services, but risk potentially imbalanced traffic spreading. Health check, node port. Load balancing services from some cloud providers do not let you configure different weights on each target. Where are the weights? With each target weighted equally in terms of sending traffic to nodes, external traffic is not equally load balanced across different pods. I don't care about that. So will this work if I set this traffic policy for type, what do we use? Cluster AP. So this should be just in the root of the spec of the service. So for gateway, let's try to do that. Okay. Hello, Black Beverage. I am doing good. How are you doing? So this actually runs. Let me double check. So now for the gateway, service, and this. So this now should have this option, external traffic policy. Well, I didn't see it on this page, but it should be present in here, yeah. So it is updated. Now, what would happen if I would try to connect? To my gateway server. I can't for some reason. Did I? No, this should be still good. Maybe the AP is wrong. Yeah, the AP is wrong. This needs to be this. Now let's try to connect. So it did connect, but there was something wrong. Let's see, gateway. Which one was it? Is this my local IP address within that network? Wait. 172.29.229. Yes, this is actually my host computer in the virtual network. Huh. It was that simple. It was that simple. So what's wrong with the login now? Invalid credentials. But okay, at least this is my IP, the actual virtual IP of my host machine. So this looks like it solves our problem. We don't have to actually implement the the proxy protocol, but we could theoretically. Let's read the article a little bit further. This instructs Kubernetes to maintain the original source IP address of the traffic. Finally, create a Kubernetes service and deployment. Like, dude, you could just state this in the beginning of the article and that should have been enough. Why do we need all of that? Again, we're back to HTTP. Well, the main thing is it actually works. It actually works. Looks like I do have real IP addresses now. I want to read on this policy a little bit more though. Virtual IP address and mechanism. Internal traffic policy and external traffic policy fails to control how Kubernetes routes traffic to healthy, ready backends. External traffic policy, this is what we are using. You can set the external traffic policy field. Is this the same that we were looking at? To control how traffic from external sources is routed. Valid values, a cluster. Yeah, this is what we were looking for, I think. No, maybe not. Cluster and local. Set the field to cluster to route external traffic to all ready endpoints, and local to only route the ready node local. What the hell? If the traffic policy is local, there are no node local endpoints. The kube proxy does not forward any traffic to the relevant service. What? Yeah, I guess these topics are not talking about the actual IP address preservation, but something more in terms of the actual load balancing. Source IP for services with node type port. So packets sent to services with node type port, a source netted by default. You can test this by net service. This is not what I'm looking for. Load balancer. Huh. They're actually not talking about what are we using? Cluster IP. We're using cluster IP with this policy, and it actually works. So why do we have trouble in getting the correct source IP for SNMPTD whatever pods in Zabbix? So yeah, in this thing, in this pod, external IP, it changes to some pod IP, yes. I also faced the same issue and fixed it after adding external traffic policy local to that service. A service with a node port is a virtual entity managed by 𝙽𝙴𝚁𝙀. This address port combination is available on every node in the cluster and forwards any local pod service traffic to the remote IP and port. This setting makes a node port service to use only a local pod to service the incoming traffic. This avoids a network hop, which removes the need to write the source of the packet via NAT. This results in real network IP arriving at the pod service in the connection, rather than one that cluster nodes being source IP. Virtual entity managed by 𝙽𝙴𝚁. This address port combination is available on every node and forwards any local pod service traffic to the endpoint's IP and port. This settings makes node port service use only a local pod to service the incoming traffic. I don't know how this works. I hope that it works. But yeah, I will test this on a proper Kubernetes setup when we have it. For now, I call it good enough. So, let's commit that to the repository as a separate thing. So, retain the real client IP address for gateway services. Okay, what about this thing? Why can't I connect? Invalid credentials. I assume this is because changed the settings a little bit. And by default, login server now has username and password authenticator disabled. So yeah, I should define it here, and that should fix it. Wait, I need this to be true. But yeah, as a backup plan to this thing that we've set in the service, maybe it wouldn't work on a real Kubernetes proxy, on a real Kubernetes cluster. I could implement that proxy protocol on my gateway and make it like a switch to enable or disable it. So when we receive a new connection, maybe we can tell Kubernetes to actually send this proxy protocol header first. We get the real IP address from that header, and then we process the connection as usual. That would be one thing. Another thing is maybe we can actually configure our gateway as an actual ingress. I don't know. Okay, let me try to connect now. Okay, now it works. But I have one thing to configure, one more thing. So yeah, now I can actually connect. Let's see, login server. This thing. Okay, so I can basically just copy that to my Kubernetes login server. And that should do it. Okay. Now what? I wanted to see if I can make this deployment of gateway servers to be actual daemon sets, but I don't think it's a good idea, to be honest, because that looks like it's gonna be a much more complex topic. I actually need to make it in a similar way that Nginx ingress controller works. Maybe that's gonna be for later. So what do we need now? So I saw somewhere in Kubernetes that we can expose the metrics endpoint and it will collect the metrics for a pod. This is not what I'm looking for. Where was it? So we have some pod metrics, but there was something that you could configure and it would like scrape the metrics from the pod's endpoint, its own metrics or something like that. Um, I'm not sure, to be honest. Like, I thought it's some kind of meta attribute. Maybe some kind of label that specifies how you can collect the metrics. But here I can actually see a service monitor type. That's not it. Scale and custom metrics. I think I'm looking in the wrong place. Where can I find the reference to a deployment? I don't remember it, but there was something. And I can't even remember where can I look for an example where I saw that. Like my pods, not pods, but yeah, technically, my application can expose Prometheus metrics on an HTTP endpoint. I want to try and use that inside the actual Kubernetes cluster. Not sure if I can though. Custom metrics API. What the hell is this? This is not what I'm looking for. But how do you create these custom metrics? That's the question. Like, let's say my application has a specific metric called, I don't know, clients connected or something like that. What if I want to scale my gateway servers based on that metric? Okay, so custom metrics are not built into Kubernetes by default. Adapter API servers provided by custom solution vendors. So maybe if I put Kubernetes into the cluster, it will get me this. Not Kubernetes, but Prometheus. Yeah, this is what I was looking at. Let's see. Prometheus. What is this? Prometheus adapter. This repository contains the implementation of the Kubernetes custom resource and external metric APIs. This adapter is therefore suitable for use with the autoscaling v2 horizontal pod autoscaler in Kubernetes 1.6 plus. It can also replace the metric server on clusters that already run Prometheus and collect the appropriate metrics. Config walkthrough. You're a Helm user, Helm chat is listed, yes. So I just install the chart. The adapter takes the standard Kubernetes generic API server arguments, including those for authentication and authorization. The adapter generates the names of available metrics from Prometheus at regular intervals, the configuration above, and then only exposes metrics that follow specific forms. Oh, here we go. So cluster configuration. Before getting started, ensure that the main components of your cluster are configured for auto-scaling and custom metrics. As of Kubernetes 1.7, this requires enabling the aggregation layer on the API server and configuring the controller manager to use the metrics API via the REST clients. Tail instructions can be found there. Make sure that your properly configured metrics server as default in Kubernetes 1.9+. For enabling custom metrics auto-scaling support, we will disable CPU auto-scaling support. Suppose that you've written some new web application and you know it's the next best. Okay, it's ready to enable the wall, except you're not sure that one instance will handle the traffic. Yeah. Deploy your app into the cluster exposed by a service so that you can send traffic to it and fetch metrics from it. So, okay, we need a service for that, right? So this is the deployment, anything special? No, container, how to scale demo, metrics provider, have an HTTP port. And we have a service, cluster AP, port HTTP 80. Okay. So we have just a basic HTTP app. Now check your app, which exposes metrics and counts the number of accesses to the metrics page via the HTTP requests total. So okay, we have that. Notice that each time you access the page, the counter goes up. Now you'll want to make sure that you can auto-scale your application on that metric so that you're ready for your launch. You can use a horizontal pod autoscaler like this to accomplish the auto-scaling. So, API version v2. Okay. So we point this to the deployment to scale between 1 and 10 replicas. Metrics. Use the pods metric, which takes the average of the given metric across all pods controlled by the auto-scaling target. So metric HTTP requests. If you try creating that now and take a look at your controller manager logs, you'll see that the horizontal pods autoscaler controller is attempting to fetch metrics from APIs, custom metrics IO, pods, HTTP request selector. But right now, nothing's serving that API. Okay. Before you can autoscale your application, you'll need to make sure that Kubernetes can read the metrics that your application exposes. Launch Prometheus and the adapter. In order to expose the metrics beyond CPU and memory to Kubernetes for autoscaling, you'll need an adapter that serves the custom metrics API. Since you've got Prometheus metrics, it makes sense to use the Prometheus adapter to serve metrics out of Prometheus. I see. So yeah, I guess I was wrong. I think I starting to remember now. I think I saw that like metric endpoint specification somewhere in the Prometheus docs. So when you install Prometheus into Kubernetes, you can define like labels that will tell Prometheus where it can collect the metrics. I think that was the thing. And then this adapter exposes the metrics that Prometheus have collected from your application and exposes that to the cluster, so then you can use it in the horizontal pod autoscaler, for example. First, you'll need to deploy the Prometheus operator. For the operator to deploy a copy of Prometheus. This walkthrough assumes that Prometheus is deployed in the monitoring namespace. Most of the sample commands and files are namespace agnostic, but there are a few commands or pieces of configuration that rely on that namespace. If you're using different namespace, simply substitute that in the monitoring for monitoring. So monitoring your application. In order to monitor your application, you need to set up service monitor pointing at the application. Assuming you've set up your Prometheus instance to use service monitors with the app sample app label, create a service monitor. What does that mean? Assuming you've set up your Prometheus instance to use service monitors with the app sample app label. I guess when I install Prometheus in the cluster, I need to do that. Create service monitor to monitor the app's metrics. Okay. Match labels, endpoints, port HTTP. Now you should see metrics HTTP request total appear in your Prometheus instance. Look them up via the dashboard and make sure they have the namespace and pod labels. If not, check the labels on the service monitor, match the ones on the Prometheus CRD. So now I have a question. What if I have an external Prometheus instance? Let's say it's not in the cluster, it's somewhere else, and it's collecting the metrics. Can I use this adapter to fetch the metrics from that Prometheus instance? Launching the adapter. But I don't think that would make sense if I deploy the application to Kubernetes. Because in my current setup, Prometheus actually actively scrapes every endpoint that I define on every machine and collects them. It's not gonna work with the cluster because I'm not gonna have public IP addresses for everything. Oh crap. So I guess I would have to set up probably a separate Kubernetes instance, not Kubernetes, a separate Prometheus instance. I don't know. Okay, launching the adapter. Now that you've got a running copy of Prometheus that's monitoring your application, you'll need to deploy the adapter, which knows how to communicate with both Kubernetes and Prometheus, acting as a translator between the two. However, an update to the adapter config is necessary in order to expose custom metrics. Config map. What is this for? Adapter config. What is this? This adapter configuration should work for this walkthrough together with a standard Prometheus operator configuration. But if you've got custom relabeling rules, or your labels above weren't exactly namespace and pod, you may need to edit the configuration in the config map. Configuration walkthrough provides an overview of how configuration works. So yeah, I guess it actively queries specific metrics from Kubernetes and exposes them as metrics. Huh. Can I deploy this thing to a cluster but use an external Kubernetes Prometheus instance? Listener keep config. Prometheus URL. This is the URL used to connect to Prometheus. It will eventually contain query parameters to configure the connection. How can I configure that? The adapter itself takes the standard. Okay, where is the Helm chart? Values. Prometheus URL. Here we go. So I guess I can point it to an external Prometheus instance, right? But I'm not sure if that's gonna be actually useful. Okay, and these are the rules. So I can configure all of that from the Helm chart. I don't know, to be honest. So Prometheus operator. This is Prometheus adapter. Creates, configures, manages Prometheus cluster, setup Kubernetes. So probably the best way of doing all of this would be to deploy this Prometheus operator into the cluster so it can automatically link and scrape all the metrics that I have in my server application across the whole cluster. And then I can use this adapter to export certain metrics to Kubernetes itself, right? Okay. And then I can probably use the autoscaler from there. The thing is, I already have a Prometheus instance that collects metrics from various places. Not just the game server, the currently running instance of game server, but all other services. And I don't think I'll be able to use it then. So I will have like two Prometheus instances. One is for the Kubernetes cluster, another one is for everything else, unless I can figure out how I can export metrics from one Prometheus instance to another, from the one that's in the Kubernetes cluster into the one that I have external. So Prometheus operator provides Kubernetes native deployment and management of Prometheus and related monitoring components. The purpose of this project is to simplify and automate the configuration of a Prometheus-based monitoring stack for Kubernetes clusters. So Kubernetes custom resources. Use Kubernetes custom resources to deploy and manage Prometheus, Alert Manager, and related components. Simplify deployment configure. Another way would be to actually use a separate Prometheus instance for my cluster. Maybe that would make more sense. And I have separate alerts, for example. Maybe. Simplify deployment configuration. Configure the fundamentals of Prometheus, like versions, persistence, retention policies, and replicas from a native Kubernetes resource. Prometheus target configuration. Automatically generate monitoring target configurations based on familiar Kubernetes label queries. I need this. No need to learn a Prometheus specific configuration language. Getting started guide. At least these Prometheus related stuff I actually documented nicely. Prometheus operator versus kube-Prometheus community Helm chart. So Prometheus operator uses Kubernetes custom resources to simplify the deployment and configuration of Prometheus Alert Manager and related monitoring components. kube-Prometheus provides example configurations for a complete cluster monitoring stack based on Prometheus and the Prometheus operator. This includes deployment of multiple Prometheus and Alert Manager instances, metrics exporters, such as the node exporter for gathering node metrics, scrape target configuration linking Prometheus to various metrics endpoints, and example alerting rules. So it looks like this is a more powerful thing. Helm chart provides a similar feature set to kube-Prometheus. This chart is maintained by the Prometheus community. Okay, maybe I need the Helm chart actually. kube-Prometheus. What do I have here? Status failing. Sure. Components included in this package. Prometheus operator, highly available Prometheus, highly available Alert Manager, Prometheus node exporter, black box exporter. What is this? I don't think I've seen this. Black box prober exporter. Probing of endpoints over HTTP. I don't know. Prometheus adapter for Kubernetes metrics API, kube state metrics, and Grafana. So yeah, I definitely want this, at least. What is this? Kube state metrics. Add-on agent to generate and expose cluster level metrics. Okay, I guess this is for Kubernetes itself, like monitoring the Kubernetes itself. And it has Grafana. This stack is meant for cluster monitoring, so it is pre-configured to collect metrics from all Kubernetes components. In addition to that, it delivers a default set of dashboards and alerting rules. Many of the useful dashboards and alerts come from the Kubernetes Mixin project. Similar to this project, it provides composable JSON-net as a library for users to customize to their needs. So you will need a Kubernetes cluster. That's it. By default, it is assumed that the kubelet uses token authentication and authorization, as otherwise Prometheus needs a client certificate which gives full access to the kubelet rather than just the metrics. Token authentication and authorization allows more fine-grained and easier access control. Oh, Minikube. To try out this stack, start Minikube with the following commands. Minikube delete, Minikube start, container runtime, container D now. Kubernetes version, memory, bootstrapper, extra config, kubelet authentication, token webhook, extra config scheduler. The Kubernetes stack includes a resource metrics API server, so the metrics server add-on is not necessary. Ensure that the metrics server add-on is disabled. Wait, so how does this installs or... To try out this stack, start Minikube with the following command. I don't think this actually includes anything specific to Prometheus here. So runtime docker d version, memory, bootstrapper, kube atom, kubelet authentication token webhook, kubelet authorization mode webhook, extra config scheduler, bind address, extra config controller manager, bind address. So yeah, I guess this is just because the default Minikube installation wouldn't allow me to deploy this stack into the cluster. But yeah, I cannot use containerd because I'm on Windows. But that should be fine. Okay, what about the Helm charts? Install core components of the Kube Prometheus stack, Grafana and dashboards and Prometheus rules combined with documentation and scripts to provide easy to operate end-to-end Kubernetes cluster monitoring. This chat was formerly named Prometheus operator. Okay. By the way, what is my Helm version? 3. Okay, good. With Prometheus operator version 0.30 plus, the core Prometheus operator pod exposes an endpoint that will integrate with the validation webhook configuration Kubernetes feature to prevent malformed rules from being added to the cluster. Okay, can we try how do I try this? Okay, so I should have the chart. Okay, it just says install. How do I configure it? Guess I need a local values file. This is the default, I guess. Oh, I don't know. Let's just try to deploy it with the default settings and see what happens. Hey, that's upgrade. Oops. Okay, so what do I have? It's been installed. Check the status by running this. Crap, it installed in the default namespace. Hmm. Okay. What? Oh yeah, I guess it's in base 64. I don't have base 64 on Windows. Oops. Wait, where is my Grafana? Okay, so now here we should have Grafana. Okay. But yeah, to access it, I need an actual password, which is there. And that's admin. And the password is this, but I need to decode it from base 64. Okay, so we have a Grafana here. And where are the dashboards? They were promising dashboards. Oh, there we go. Alert Manager, coordinates, etcd, Grafana overview, Kubernetes API server. Okay, kubelets. Okay. Well, okay, this looks promising, right? Running pods. Can I see individual pods? And which one uses what? Do I have Ymirheim server running there? Yes. How can I see that? Interesting. Hmm. I'm not sure. Is it even useful? But okay, we have Prometheus here, right? Now what? Prometheus adapter, it should be in there, right? Yeah. So how does that work now? This adapter is an extension API server, and Kubernetes needs to have this feature enabled, otherwise the adapter has no effect, but it's still deployed. Extension API server. I have no idea. Okay, let's say we have this adapter running, right? How do we export some metrics? So let's say it's configured, it's in its default configuration or whatever. We had that walkthrough somewhere. So I guess I need something like that. I was pretty sure that I can just define certain label and it will automatically scrape the endpoints defined in that label. I don't know. So probably not. Also, why don't I see even like default metrics for running pods? No data. Like it has the stats. It has 26 pods running. Operation rate. What is this? I have no idea. Oh, but okay, back to this thing. So let's say we have our Prometheus, and we have the Prometheus operator. We have the application. We don't have the ports exposed though. Let's see, maybe we can do that. Maybe we can expose the ports. Yeah, deployment. Let's see, what are the default ports? So let's say gateway server. Monitoring Prometheus 6901. Oh. Well, we can do name matrix container port 6901. Now I'm pretty sure I need to actually enable Prometheus like that. Something like that. Or maybe that would be for the global or general. Okay. So we enable Prometheus. We added another port for matrix. Right. We also need to expose the port in the service. Matrix. So for gateway, for example, matrix 6901. Okay. All right, now this thing is running. Okay. So now we should have it. So services, gateway, matrix. Wait. Why is it? I don't know. Should be fine. Can I thought that I could proxy an endpoint from the dashboard itself somehow. Why can't I connect to it though? Maybe it has to be a public endpoint. No, shouldn't matter. Actually, yeah, maybe. It should work. So let's say we have monitoring Prometheus, scrape endpoint 6901 for the gateway server. We have it enabled. Let's just in case go enable this thing. So we have it enabled. 6901. In the deployment, we have port named matrix 6901. Yes. In the service for gateway, we have port matrix 6901 pointing to matrix. I mean, we can also try the TCP, but it shouldn't matter. '6901, and it should actually expose this port to the cluster AP, to external service APs. I don't understand why it's not working. It should work. Why is this cluster AP different? Huh. I don't understand. Pods are failing. Ah. The request is not supported. Fatal. HTTP listener cannot be started. Interesting. So wait. Now starting failed. Prometheus HTTP listener cannot be started. The request is not supported. What? The request is not supported. What the hell is that? This is how HTTP listener works. Do not use 0000. Use asterisk or plus if you want to listen on all addresses. Why? Okay, sure. Let's use asterisk. Okay, so theoretically it should be started. There we go. There's our metrics. Okay. So I have the metrics. I have the metrics. I have the service. Okay. Horizontal pod autoscaler. We're not touching that for now. I just want to get these metrics into Prometheus. Launching Prometheus. So first we need to deploy Prometheus operator. We have that theoretically. Prometheus is deployed in the monitoring namespace. Service monitor. In order to monitor your application, you'll need to set up a service monitor pointing at the application. You know what? First of all, let's try to uninstall our Prometheus. Because I want to put it into the monitoring namespace. How we do that again? Can I specify a namespace here? Here, namespace. Okay. Install. Namespace monitoring. Let's see if that works. Namespace monitoring not found. Because yeah, I want my Ymirheim in the default namespace, but all of this should be in the monitoring namespace. Okay. Okay, so this should be our Grafana. Let's put it there. Okay, so we have that. If we switch to monitoring namespace, yes, that's our Prometheus. Back to default, that's our server. Nothing else. Perfect. So now we still have our metrics, that's perfect. Now we need to teach this thing to collect these metrics. Ow. So we have that in the monitoring namespace. Monitoring your application. In order to monitor your application, you'll need to set up a service monitor pointing at the application. Assuming you've set up your Prometheus instance to use service monitors with the app sample app label, how can I do that? I have no idea. Declaratively specifies how groups of Prometheus services should be monitored. The operator automatically generates Prometheus scrape configuration based on the current state of the objects in the API server. So this is what I need to create. How do I teach it to listen to the service monitors? I have no idea. Let's just try to create this, which means I can create new app dash service monitor YAML. Let's put this thing here. So match labels. That should be that should point to the app in a same way that this thing is pointing to it. So let's create that for every app instance. You can copy the labels. And for now, I want to make it work only for gateways. Okay, so I have this service monitor, Ymirheim server default, selector, app name. This isn't correct. What's wrong with it? 6. Release name. Endpoints, metrics. Okay. So theoretically, we should have... I don't have the service monitor. Customer source definitions. Service monitor. Have this object. Okay, so it's there. It's there. Scaled up. I don't know. No conflicts. So now, can I somehow see it somewhere, anywhere? I'm not gonna have a dashboard for this. I don't remember how to manually query Prometheus for this thing. You should see your metrics appearing in your Prometheus instance. Look them up with a dashboard. Make sure they have the namespace and pod labels. If not, check the labels on the service monitor. Match the ones on the Prometheus CRD. Explore, I think. Um, I don't have it. I don't have the metrics. Okay. So I guess I'm missing this step. Assuming you've set up your Prometheus instance to use service monitors with the app sample app label, create a service monitor. How can I configure that? Set up your Prometheus instance to use service monitors. Quick start guide. So adapter exports the data from Prometheus into Kubernetes. Service monitor should tell Prometheus to scrape certain endpoints. Can I see that somewhere? Data sources. Monitor in all namespaces. Hell. Like, what the hell? Cube Prometheus stack values. Default roles create for monitoring the cluster. All true. So what am I looking for again? Service monitors. Windows exporter. Service monitor for alert manager. I don't understand. Looks like there is a lot of these service monitors. Yeah. There is a lot of them. Maybe it's not catching my service monitor because it's in a different namespace. But yeah, I don't see the service monitors here. Probably this is, yeah, this is just for Grafana. It's not the Prometheus thing. Let's see. Monitoring services. I don't remember. Prometheus. Wait, administration, what do we have here? No. No. This is just for Grafana. Huh. What is this? Prometheus. Service monitor selector. To be selected for target discovery, select all service monitors. So okay, it should catch every service monitor. Namespace. Should be everything, I guess. Monitor selector nil uses Helm values. True and nil are empty value for Prometheus spec, pod monitor selector will cause the Prometheus resource to be created. Select, I don't know. I have no idea. Maybe we can find some blogs that describe how to work with this. You'll need to set up your Prometheus instance to start scraping your services or pods directly using a service monitor or pod monitor, and define custom metrics endpoints on your containers that expose Prometheus metrics specific to your tasks. Okay, so we installed this thing. We did that. We verified the installation, configuring a service monitor. Sample application and a service. We have that. Service. Just to double check, what do they do? Ports, container port 80. Okay. Service. Web 2. Okay. Create a service monitor. Create a service monitor to scrape metrics from the sample application. Ensure the following steps. Metadata labels. The labels should include a release name that matches the Helm chart release name. In this case, this thing. Hello, 𝙽𝙴𝚁𝙸𝚂. Selector match labels. The selector should match the labels in your service YAML. It should work. But let's double check. Service monitor. This one. Should be fine. Metric path. Ensure that the metric path is set correctly. Metric path. Maybe I forgot about that. I don't know. Maybe I should define this in state/metrics. Confirm service monitor communication. Ensure the service monitor can communicate with the service by verifying the logs and checking if Prometheus is scraping the metrics. How? How? Verify metrics collection. Yeah, I was looking for this interface. Should I begin collecting metrics? I can confirm this is in Prometheus dashboard. Prometheus dashboard can be exported by forwarding the service. Okay. So I'm looking for service monitor cube from Prometheus. A service. Monitor cube from Prometheus. What? I guess this. Oh, it actually looks for pods. I mean, I don't remember how to do this. Can you just give me an example use? Okay, Prometheus. 1990. There we go. So here, status, service discovery, maybe, probably not. Target health, right? No, service discovery, actual service discovery. Okay, wait. Prometheus Cube Controller Manager. Prometheus. What is this? Oh my god, it's lagging. Lagging real hard. Oh my god. Why does it type that? This is not what they wanted to type. In their case, the application and Kubernetes are in the same namespace. Maybe that's the problem. I wanted to deploy Kubernetes into the monitoring namespace. I'm sure this matches your Prometheus configuration. Maybe this is the problem. Maybe this is the problem. Where do I define it? In the metadata after the name. What is this? Well, this is actually weird. I don't remember the interface being like that. But okay, let's see. Maybe now it collects something. No. Okay, let's try and deploy this thing to the default namespace. Maybe that's the problem. And I just can see the data from the other namespace. So this is uninstalled. We don't have anything here. Now let's install it back into the default namespace. So if I look at custom resource definition service in the default namespace, there's my service monitor. So I need my Grafana. I don't see the metrics. I have no idea. It doesn't see it. Why? So Prometheus should now begin collecting metrics. You can confirm this in the Prometheus dashboard. Prometheus dashboard can be exposed by port forwarding. Access the Prometheus dashboard by port forwarding. Yeah. Yeah, it's not there. So what if I uninstall, right? Let's see what's in this example. Monitoring CoreOS. .com v1, yeah. Service monitor. Namespace. I'm not gonna do that. Labels. Sure, this matches the release name of your Prometheus instance. Selector. Match labels. Endpoints, port, metrics. Service monitor. Name, release name of our service. Default. Gateway default is labels. Everything else doesn't matter. Spec match labels. Gateway default. Release name. Looks good. So this should be working. There we go. So these are the metrics. And I don't have it in the scrape pool. Why? I have absolutely zero idea. So it should match all monitors. This is the default values. Common problem related to service monitor identification by Prometheus is related to the object labels not matching the Prometheus custom resource definition scope, or lack of permission for the Prometheus service account to get, list, watch services and endpoints. As a general guideline, consider the diagram below. So yeah, looks like I have to create the service monitor resources within the monitor namespace, and it can point to custom namespace. But okay, right now they're both in the same namespace. So service monitor references a service, not a deployment or a pod, by labels and by the port name in the service. Should be good. This port name is optional for Kubernetes, but must be specified for the service monitor to work. It is not the same as the port name on the pod or container, although it can be. Has my service monitor been picked up by Prometheus? Service monitor objects and the namespace where they belong are selected by the service monitor selector and service monitor namespace selector. So it should be all namespaces, all services. The name of the service monitor is encoded in the Prometheus configuration, so you can simply grab whatever it is present there. The configuration generated by Prometheus operator is stored in Kubernetes secret and named after the Prometheus object name prefixed with Prometheus and is located in the same namespace as the Prometheus object. What? But okay, that means that I should be able to see secret. So Prometheus, what? Which one? Configuration generated by the Prometheus operator is stored in a Kubernetes secret named after the Prometheus object name, prefixed with Prometheus dash, and is located in the same namespace as the Prometheus object. For example, for a Prometheus object called K8s, one can find out the service monitor named my service monitor has been picked up with I guess this one. Gzip file, 52 bytes. Doesn't look like much. You can also use port forwarding to access Prometheus web. Yes, in the contract successfully, you should access the Prometheus server UI via localhost, where you can check the live configuration and the discovered targets. Where can I see the configuration? There is nothing about Ymirheim. Nothing about the gateway server. Match labels, release Prometheus. What is this? Are you kidding me? The release needs to be Prometheus. Why? Why? I don't have any other questions, just why? But okay, labels. Release. It was Prometheus, right? Prometheus. Give me upgrade. Still nothing. Okay, match labels, release Prometheus. That should be now fixed. Let me also double check the namespace selector. It's empty. But yeah, it should have match labels, release Prometheus. Now, if I open service monitor, this one, release Prometheus. Maybe I need to get rid of that and only have the release Prometheus. Or maybe it's just slow and it's gonna pick it up. Oh my god, there it is. There it is, there it is, there it is. And it actually picked up metrics from both instances. Well, yeah, I cannot access that from my browser. But yeah. So I should see it here now. There we go. Why was it so hard? Why? But okay, I understand now. So when creating service monitors, I need to create it in the same namespace as the metrics Prometheus. And I should also create the same labels. So the release name should be the same. So this should be configurable, and also I should have a namespace something that matches the Prometheus. Okay. But okay, we have metrics now. Zone connections. Can I forgot how to use this. Oh, there we go. It just didn't update. Okay, so we have 10 connections. Sure. And we have container, Ymirheim server, endpoint metrics instance, job, namespace default, open telemetry, pod, and service. That's not enough, I think. I need to assign labels somehow. Probably I can do that with this service monitor. Let's write it down. So to do assign labels to the metrics. Service man. I probably can see the definition here. Spec affinity. Wait, that's Prometheus. I was supposed to look at this. Endpoint selector. Yeah, I need to find the documentation for this one. But okay, at least it works. We can try to customize it later, but at least we figured out how to pull the metrics into a Kubernetes instance. And we figured out how to install a Prometheus instance. So we have a Prometheus instance. That Prometheus instance looks for the service monitor definitions. Service monitors point to specific metrics endpoints in my application. And so Prometheus pulls the metrics that we can see here into itself, and then it becomes available. So yeah, I need to improve the labels for this. Like, there should be a way to append labels, because you can do that in the Prometheus config. This is what I'm doing, but I don't see how to define those in the service monitor. Should be possible. There is interval, port scheme. I don't know. I would have to look into the documentation and see how to do that. But it's running. That's good. Yeah. So yeah, this is gonna be it in terms of programming for today. I will finish this stream and I will start another one in half an hour. We will have our gaming Friday night. We will continue playing Conquerors, but for a day. But for programming today, we are done. So yeah, let's see. Can we rate somebody real quick? Pum pum pum. I'm not sure. Maybe somebody who does server-side work, if we can find anybody. I don't know. Let's raid Red Cabin Games because I don't know. But yeah, this is gonna be it for today. Today we figured out Prometheus and metrics. We reorganized configs. We fixed the problem with our client IP addresses not being forwarded properly. It works, not sure if it will work on the actual Kubernetes cluster, but it works in Minikube. That's fine for now. And yeah, and we also fixed a bunch of bugs. So yeah, next step would be to finish the service monitor to make it actually configurable and work properly. Yeah, this is it for today. I will be back in half an hour with some gaming stream. And yeah, hope to see you soon, and bye-bye.